We're on.
Yes.
All right. September 30th, 2020. I'm Brad McQuay, and I'm down on the shop floor with my partner, Balbir. And I've been on my feet all day, so I'm taking a bit of a break here. And at the same time, we're taking a picture of some dimple jacket here that is designed to go on a ASME vessel. ASME stands for American Society of Mechanical Engineers. And when we make reference to that, we mean pressure vessel. So it's a tank designed for pressure over 30 psi. But Alice feels good on the back. So you can see all these dimples here, and the dimple spacing is designed so that we can handle a certain amount of pressure in the jacket itself. It doesn't provide so much structural integrity for the tank, but it's special. And anyway, Balbir's the engineer, so we'll let him talk a little bit about this. And then that allows me to get up off the floor here too at the same time.
Hey guys, Balbir here. So yeah, today the topic we were going to discuss is basically vessels, whether it's brewery or any other process vessels on ASME and non-ASME. So the differences between them, when you need one or the other, and just some of the details and the finer things that go in one or the other. So that's what we're going to talk about. And as Brad was mentioning about the dimple jacket, that's one of the components on whether you're heating a vessel or cooling a vessel and how much pressure you want to put into that vessel and whether you need that certification. So in short, just to start with the ASME requirements, any vessel, and this is Canada and pretty much rest of the part of the world as well. The only ASME is sort of accepted in most of the world. I know Europe does have their PED, which is Pressure Equipment Directive, so it's basically very similar but slightly different requirements. And then Australia does go with ASME, but they'll have their own work safe requirements as well. So overall, widely accepted code. So for pressure vessels, anything for the internal of the vessel that's greater than 15 PSI requires to be ASME certified. And if it's 15 or under, it can be a regular process vessel. You do not need to get certification. The manufacturing is pretty much still the same. The requirements are going to be some of the quality stuff, the inspections, and obviously the registration process. So we will go through some of that today. Here we can show you, just if you want to follow this way, is a larger vessel that we're working on here that is an ASME vessel. So this particular one, we are going through all the inspections and everything else on that. So before getting into too much detail, we'll talk a little bit about, like I said, about when it's required or not. So if in that vessel, like for example in the brewing industry, which we're basically talking about, most of the brew house vessels do not require it. They're atmospheric, so they do not require the vessel themselves to be ASME certified. But the jackets in turn can. So if you have jackets that are heating that vessel and it's 15 pounds steam or less, we're fine. We can just be, they don't need to be ASME registered. But if you want to put higher steam into those vessel jackets, then we would have to register those jackets under ASME. Now we move on to sort of the seller side, fermentation. I would say 90% of the time fermentation vessels do not require ASME. We do have some clients that specify that and want ASME, which we can do. But in most cases, 15 PSI is sufficient for those vessels. And then on the bright tanks or serving tanks, what you want to call them, those vessels can. We've got clients, I would say those are like a 50% depending on what you're going to use them for. If they are going to be just used as conditioning or carbonating or serving vessels, in most cases you do not need ASME. 15 PSI is plenty. But if you are using it as a sort of a buffer tank to serve your kegging or packaging line, whether it's bottling or canning, in that case you may need higher pressure to supply to that packaging line. And in that case, you may need 30 or you may need 45, so you may need that higher pressure. So that requirement will come depending on what type of packaging equipment you have. And most people, and even then you still have an option if you want to go higher pressure on the vessel, so you're spending more money on the vessel, or if you want to put in a booster pump and increase that pressure. So there are still options in that sense as well. So yeah, I mean, if there's any questions on this topic, please shoot them our way, or we'll have a look at that. And you can read them out to us, and we'll also answer those questions as well, if there's any other detail. Okay.
Okay, Balbir, on this jacket that we have on the floor, even though the client hasn't really specified the jackets needing to be ASME rated, explain why we still have to follow the same procedures based on the tank.
Yeah, once you have a registered vessel, basically you have your pressure containing component, which is the big vessel inside. So there's a pressure for that vessel. In this case, this vessel is going to be 30 psi, which is fine. So anything, basically that whole shell, the head, everything for that vessel has to be rated for 30 psi. The jacket here, it's got a rating of 35 psi. This is again cooling, so this is basically a big bright tank. So this is going to be cooling, so we're going to be doing 35 psi. Normally, because of the temperature, because we're less than 65 Celsius or 150 Fahrenheit, we can go higher pressures, more than 15 on jacketing, and particularly this type of jacketing, the dimple style jacketing. We can go higher pressures as long as we're within that temperature and not need ASME requirement. Because this whole vessel is, then everything is basically ASME. So the vessel, the jackets, everything becomes ASME. And like Brad said, the way we change pressure ratings on our dimple jacket is the spacing of the dimples themselves. And then you can also increase thickness as well, but spacing is usually the first thing we do, so we can just change that from what you hear is almost like a 2-inch spacing from the dimples. You can go to 3 to 4 to different types of spacings.
Okay, on the material itself, though, you might want to mention something about the traceability or that sort of thing, because even though this isn't ASME, it's still one weld away, so that still
yeah, and all ASME actually. Yeah, so this does definitely. So material traceability is also a big component with ASME. So once we purchase what the material we need for that job, it's traced all the way from a purchase order to our receiving to a mill test report that's required from the mill that made that material. So when this stainless was made at a mill, doesn't matter where in the U.S. or where in any parts of the world, they have to provide, or the distributor where we're purchasing this from, they will get that mill test from the mill, and then in turn give it to us. That mill test report has to have basically all the details of when that material was formed. So that has all the chemical composition, the mechanical properties, and how you sort of the traceability is from the actual markings. Where if you want to sort of come in a little closer here, you can see the markings on the material. In most cases, they're stenciled in. So then you'll see that there's a heat number on there.
That provides traceability.
Yeah, so that traceability, we can take that marking right on the sheets here, and then correspond that to the actual paper mill circuit we get. These days it's stamped digitally. So we know this is the exact one, and we can check the chemical composition and make sure it meets the ASME requirements. They have certain limits that they allow the material chemicals to sort of ranges that they're acceptable. And if that meets it, then we can use it for this job. If it doesn't meet it, we would actually have to do a non-conformance and say this is rejected for this reason. So in most cases, the mills are pretty good, and it's all it normally meets the requirements of ASME. In fact, they're usually stamped ASTM as well as ASME right on the material itself. So they're very well aware of that. Any other questions?
Yeah, on when you look at the welding that goes into place here and that sort of thing, it's one of those things where you just can't get someone off the street and say, okay, do welding on an ASME tank. And even internally, it's the same thing. Someone needs to go through, your certification process or something like that?
Yeah, well, there's two things. First of all, we have to qualify the weld procedure. So we write up a weld procedure in terms of what sort of technique, whether it's TIG welding, MIG, or what type we want to use. In this case, it's TIG for sanitary design. So we've registered our weld procedures here with the local BC Safety Authority. We're in BC, so we have to register with BC Safety Authority, who work with ASME on this. So they're our inspecting body locally. So we register our weld procedures. So that's sort of the first part. And then the second would be to qualify their welders. So the welders will have to do a test coupon. And when registering a weld procedure, that test coupon actually gets destructive tested. So they actually break it up into small test pieces and then actually and sometimes do tensile tests or bend tests to find what kind of stresses it's capable of and see where it fails. And as long as that's above the stress values that are required, then that passes. So we would send that out for non-destructive examination. And then when qualifying just the welder, we would do, again, test coupons of whether you want to do plate, pipe, and that gets sent out for x-ray. So when you're just qualifying a welder, they can just qualify under x-ray. So we do a weld and then we'll get x-rayed, and then they'll look at the x-ray and see if there's any impurity. And then again, it has certain criteria that weld has to meet to pass. And if it passes, then we can do a welder qualification. And so we have a new welder that's qualified to that weld procedure.
What can an inadequate weld mean for a brewery?
An inadequate weld, I mean, so if you have, it depends on what kind of...
Inadequacy.
Inadequacy. I mean, if you have, let's say, porosity, or if you have, in any ways, it would mean, premature failure would be the quick answer. So especially on a pressure vessel, it's because this is very structural in the sense that we want to make sure it can handle the pressure. So if you have, whether it's undercut or whether you have slag, which usually doesn't happen in a TIG weld, but you can have excessive heat and have burn through. And that burn through, because you're basically burning away some of the chromium in the stainless steel, that can actually create rusting, because you burnt away some of that protective elements that's inherent in this material. So there's lots of, depending on what the issues are, like burn through, or if there is porosity, that again, porosity can cause, because basically the layer bubbles in the weld, and then over time, due to the stresses of the tank, being under pressure and not being under pressure, they can form cracks that can go either inside, outside, and then you can have leaking. So definitely at the end of the day, you have a vessel that will not last as long if you have those issues with the welding.
All right, Corey, come on over here. I just want to point something out. I got another question for Balbir, and that's, we got 304L here. What's the significance of we know it's 304 stainless, but there's also an L, Balbir.
Yeah. The L, again, basically, that's a grade of the material, grade of the stainless steel, 304. We all know there's a 316 as well. And both of these, and there's 400 series as well, so there's all types of stainless steel. But the 300 series, the 316 and 304 are the most common used in brewery and most food processing applications. And the L, it signifies in both categories, 316 or 304, is a lower carbon content. So in this particular material, I was talking about the ranges that's acceptable by ASME, the chemical composition. The L has a lower carbon, there's lower carbon content in that L. That's an easy way to remember it, L for lower. So there's actually, that range is lower, so that when you get that mill test report, you have to compare with the 304L specification, and actually it's quite a bit lower range than just a regular 304. The other things that affects is the actual stress values of the material and what we can use when we do our calculations for the pressure of this tank. 304L has a lower stress compared to 304. But the advantage of 304L also is actually a better weldability for the welding compared to just 304. So,
Less inclined to crack or something like that, or?
Yeah, less cracking, and also it's just the weldability of it. It's just nice because it has lower carbon.
Okay.
We have a question.
Okay.
Where do you purchase your stainless from?
Yeah, good question. Our stainless is actually purchased. We go through distributors, and there's Ryerson, there's Samuel & Son. There's about 3 or 4. Keep in mind, this is a very good topic, because a lot of people say, "Oh, is your stainless a U.S. stainless, or is it kind of coming from China, or is it?" At the end of the day, there's mills all around the world, and the mills make that, and then it's distributed. I mean, it goes to different areas and distributed all the world. The key things I would look at when ordering raw material is, again, the mill certs and how it's produced, and make sure it meets our requirements. We've actually, I have mill certs, for example, that coming from, let's say we're buying the material from Ryerson, But I have mill certs, and the mill certs are Taiwan, for example. And so, okay, we look at the mill certs and we compare them to the ASME specifications. They meet the requirements. We have also taken little bits of stainless and tested and sent it out for lab testing to make sure that the chemical composition does meet what the mill certs are saying. Just additional QC. We wanted to make sure just to confirm that what we're getting, because this is some overseas material, and I would say every time we've done that, it has been bang on. So we trusting in the mill certs and the materials from the mills, doesn't matter if it's from Taiwan or wherever else may be in the world. That is very common in all manufacturing industry. One thing that you have to be aware of is when you're getting a finished good from a different country. That I would be a bit more skeptical about, because the material that what happens in these countries is if it doesn't meet grade, for example, if it's of top quality, it meets grade, it's exported. If it doesn't meet grade, normally the mill should, melt that down and, restart. You put that stuff back into reprocess it, right? That's very common in North America. That's what you would do. But a lot of these other countries, what they would do is they're not going to melt it down. So it's supposed to be a 304 grade, for example, a 304L grade. They're not going to melt it down. They're going to sell it locally. So in certain these countries, they will sell sort of these grades of material which didn't meet the standards for export. They will sell it locally at a lower cost, and thus the reason why you can buy very economical tanks overseas. And it's not all because of labor cost. Their material cost, we have compared their material cost for a tank, and there's no reason for it to be. For example, a tank this size, our material cost and somebody overseas material cost should be the same, because all of these chemicals that go to make stainless is a commodity. It's traded on the world market. So that, just like gold, it doesn't matter where you buy it, it should cost the same amount, silver and chromium. And so all of these things that go into you should cost the same. But we have seen material pricing overseas that is a lot lower than ours, and that doesn't make sense. So this is the only explanation. They're buying it local, and you can get inferior grade stainless when you're buying an end product. You have more control when you're actually buying the raw material. So there's something to consider.
The further answer to your question, I've seen stainless come in from, like Angle as an example. I've seen Spain written on it, and I've seen tubing come in that's from the U.S. And again, I don't know if the material is from there, but the tubing certainly was. Right. And I've seen flat bar from somewhere else, and then we've got some pipe here, which I think is from Europe as well. So it's not an easy answer to say we get it from one source. We get it from one source, like one supplier, but it's global. And as long as it meets ASTM specs for what we're doing, it's good enough for us. Okay, now I wanted to just touch on, we were talking about certifying welders. Well, that's fine. We've gone through this process. We've certified the welder. How do I know a certified welder welded this? I mean, it could have been anybody, right? So how do you keep track of that?
Yeah, so when we have actually any one of our jobs, it doesn't have to be particularly ASME, but it's keeping track of who's doing which project. It's very important to us. And so we have a project that we start initially. The inspector actually comes and initiates a traveler. So when he puts his whole points on what parts that he wants to inspect, he's inspecting more things, but there's certain parts that he'll hold and say, you can't move beyond this point until I've witnessed these things or verified these things. And one of those things is, welding is definitely a big part of that. Initially material, they inspect all the material and mill test reports, but then the next step is the welding. And so when we have our welders weld, you can see here, they have to mark their welds, like who's welded this. So they'll, right on the actual weld, they will put their number. So they actually have, each one of our employees has basically their employee number becomes their number, and they can put that next to their weld. So we know, and we actually keep a record and track of that in our QC file. So it doesn't matter 10 years from now, we can pull that file up and say, yeah, so-and-so, he may not even be working here anymore, but so-and-so, we know who welded it. At that time, he was a qualified welder at the time. This is who welded it. And so that traceability and that record keeping is very important.
All right, thanks. So we've got this tack together here. And once this weld is complete, what's the next stage? We put the two halves or two sections together. this gets welded up, let's say, and then obviously we're not going to be able to insulate and clad yet.
No, so once this is finished welded, they'll also grind the inside, because this is a sanitary vessel, we can grind the inside well. The outside left, as you can see, stays as is. So once that's done, we're actually going to put our jacketing material that you saw that was on the floor earlier. So that is going to be applied to the tank, and that gets completely welded. And then we will basically stand this tank up and do the hydro testing. So both the jacket and the inside of the vessel is going to get tested, hydro tested.
What's the pressure on this?
Yeah, so the pressure, the rule of thumb would be, this is a 30 PSI tank design. We will go 1.3 times that. So basically 30% more, both on the jacket and on the vessel itself. That's requirement by ASME. They actually don't want you to do more. So it's not like, oh, I want to do 1.5 or twice. You don't do that. It's calculated for a certain value. So you can go, they'll allow you to go 30% higher than that just for this test. And after that, you're not supposed to go higher than the design pressures, which is 30 in this case in the vessel. So at that time, we will test these to 1.3 times their design pressure, which the ASM inspector will come here. He will inspect it, make sure he doesn't see any leaks. And then after that, we relieve the pressure, and then actually we will finish off the installation. So the key thing is that he wants to see this pressurized while there's nothing else. We can't hide it with insulation. We can't cover it up with cladding. We need to be able to see it exposed, so if there is any leaking or if there is something, we see it right away. Right? So that's a key intention there. So yeah, so after the hydro, we will have some work to do our foam insulation, and then we put our cladding. And they're not too worried about that, because the part of the tank that contains pressure are done. They've witnessed that. Now it's the aesthetic part, which is insulation. It's not too big deal for them. The same thing if once we put the cladding on there, they're not worried about it, because that cladding is not welded to the pressure containing component. It's those things are already offset. So we've already seen that. They've already seen that welding. They've already seen that material. We're only welding to, 2 welds away. So which is acceptable. So
on this particular vessel, Balbir, we've got a top head and we've got a bottom head. But we've got hydrostatic pressure as well.
Yeah.
Are they the same thicknesses, or are they different thicknesses?
No, they are different thicknesses. So that is, for example, this vessel is 30 psi, but 30 psi for the top head, but then the bottom head, what do we have? Almost like 20 feet of shell here. So we have to add that hydrostatic or liquid onto the bottom head. So that bottom head could be, was it 20? It's like another 5 psi that we have to add. So instead of the top being at 30, the bottom is going to, we have to make that at 35 psi. And so that head is thicker. I believe the bottom head in this case is 3/8 and the top is 5/16. Okay. Yeah. So so it is thicker because of that hydrostatic air.
All right. So it's obvious that when you build a bright beer tank that's ASME versus one that isn't, there's quite a bit more that goes into it. And that's why people will often say, well, it's way more expensive. Well, there's a number of costs. Material costs are higher because the material is thicker. Labor is more because there's the welding takes longer because you're doing multiple. I mean, how many passes are you doing on your, say, your head weld or something like that?
The head, yeah, that could be 3. I mean, depending on thickness, it could be 3 to 4 passes. And the shell depends on thickness. In most cases, we can do the simple 12 gauges in one outside, one inside weld, and it's done. We do 2 welds just for sanitary reasons. But on these, you might have that extra pass. You might do a root and then a cap, right? So you have an extra weld. So it does become, it varies based on the size and the thickness required. And definitely there's that cost not only of material, but then you have the inspection process with ASME, the registration inspection process. Every time they come here, it's a cost, hourly that they charge for their trip, minimum 2 hours. And we've seen, I won't mention the dollar figures, but we've seen that spike in the last year or so compared to what it used to be in terms of what they're charging for this. And that doesn't come to us. That's basically coming to our hands and up to them. So it has made the pressure vessels a bit more expensive. But definitely, if that's a requirement, that is, for safety reasons, that's what you need to do.
Yeah, and the reason for going ASME is safety mostly, and a lot of the larger companies, brewing companies and just larger companies in general, they look at the liability aspect of that, and they will demand that the vessels are certified or meet some certification, and because you're dealing with pressure, it's always going to be ASME, and you have to look at the cost of extra insurance versus the capital cost of the equipment. The insurance cost is ongoing. It's something they have to pay for year after year after year. When they're looking at tanks and the capital cost is a one-shot deal, they will quite often go with that. Not always, but quite often. And it just depends on the company and what their internal policies are like. But I know the insurers are getting tougher and tougher all the time. They look at that. I know just air compressors as an example. 10 years ago, you'd have an air receiver on an air compressor, even though it's ASME rated. No one ever looked at it once it was built and shipped. Nowadays, in BC anyway, we have to register it. That receiver on the air compressor is registered. Is a pressure valve. It's registered and inspected every year, and so that's the reason behind it. I mean, obviously, on small breweries, brew pubs, things like that, a lot of people don't think they need ASME, but and the cost is significant as well. So it's their decision. But on larger breweries, larger risks, larger dollars, we see it frequently, the ASME side of things. But anyway, that's if there's any questions out there, shoot them our way. That's kind of ASME in a nutshell. Anyway, I don't know, Balbir, you got anything else?
I mean, I know that's we've kind of bored ASME to death, but with the non-pressure vessels, our code is basically the same. Obviously, we're complying with the same code, same material specs. The difference,
welders.
Yeah, same welders. The difference being, you're talking 15 psi, so you can get away with thinner materials, and there isn't that scrutiny with, mill certs, for example. We do not. In this case, they have to be kept for that material traceability, for ASME, for that record keeping. For our non-ASME vessels, we get them when we order materials. We have mill certs, but we don't generally file them and have them in a book. And so, if we need to, we can get at it, but it's not really done. So there's slightly less of, and there's no registration process, and we're not having to have a third party, come and inspect. So it makes our process go much quicker for a non-ASME vessel because we don't have any hold points. We can continuously go down, but generally speaking, the welding is still the same weld procedure, same welders, same material. It's not like we have to buy material from two different locations because ASME or non-ASME. It's all the same. It's just the thicknesses. But when it comes to fittings, there are some differences. I mean, for example, in brewery applications or any of the food prep, tri-clamp or what doesn't matter, DIN fittings or any kind of double C fittings you want to get. There's quite the standard fitting is like a 16th wall, and you can pretty much buy that from anywhere. And you can use that for a non-ASME vessel. But when you're doing an ASME vessel, you're still using tri-clamp. Now these fittings require a mill cert. In some cases, if you're registering in Canada, the fittings actually require a CRN number. So, but if it's in this case, this is going to the US, their CRNs don't apply there. So here we have to get mill certs, and that fitting is actually made out of a thick seamless pipe, and they're machined. So they're more like 1/8 thick wall, or a little more than that. So obviously those fittings do cost more. And the same goes to manways, for example. A non-pressure manway or one that's rated for 15 is going to be a lot less expensive than when you get to the ASME registered manways.
Are there size limitations for ASME tanks?
No, you can build any size. What doesn't matter if it's a 100-liter tank or like this is a 350 probably hectoliter. So it's not a size limitation. The limitations could be thickness. For example, as a manufacturer, if somebody wants a tank that's it's fairly big but also has you want 300 psi, well, what the limitation will be is the metal thickness. Like now you might need walls that are 3/4 inch thick or 1 inch thick. So then manufacturers have their limitations on what process equipment they have or fabrication equipment they have to be able to roll that, for example, or to do other things. So a manufacturer may have limitations, but ASME does not. You can build this whatever size as long as you designed it to that code to meet that pressure requirements. It's no problem.
All right. Well, that's the end of this week, and this is Wednesday, and this is the end of the month. And so we'll do this again at the last Wednesday of October. And however, I need not be around.
Okay, bring somebody else in.
You're going to have to.
And also, if you're watching, if there's some topic you want us to talk about, just, whether it's breweries, process, manufacturing, just let us know, and then we could pick that. I mean, otherwise we'll pick our own topic. But if you have something you want discussion on, we will gladly talk about that.
Yeah. All right. Well, thanks for watching, and we'll be back.
Yeah. All right. Stay tuned. Thanks.